We're working on fiber lasers for different applications, in particular identifying materials based on their chemical composition. You're already used to looking at cameras, which might be two-dimensional or three-dimensional, and some light just adds the fourth dimension, namely the material properties. It's much like fingerprinting on your own self, so each one of us have lines on our fingers. We identify each person uniquely based on a pattern of the lines. To look at a pattern of spectral lines, you need a broadband source, and so the sun provides that. But the problem is, of course, it only works from like 9 a.m. to 3 p.m. on a sunny day, and so what we do is we provide a 24/7 capability using this laser. The problem with most lasers is, if you think about your laser pointer, like your green laser pointer or your red laser pointer, that they tend to be narrow band. And so that becomes a problem of how do you use a laser to do broadband spectroscopy. So you say, well, I'll use a lamp because we know that our incandescent light bulbs or tungsten light bulbs, these are very broadband. But the problem is that if you're doing remote sensing, as an example in our test bed where we're measuring things 1.6 kilometers away, well, the light diffracts too rapidly. And again, the beauty of this light source is it stays collimated. What's unique about our architecture is, number one, we use standard off-the-shelf telecommunications parts. But the other thing is, by simply increasing the pulse repetition rate and increasing the power of the amplifiers, we can boost the output power. So as an example, 5 watts is here, 25 watts is here, and we already are working on the 50-watt design. There's very few other lasers out there that can easily take the same kind of architecture and scale up in power. We've built prototypes and higher power tabletop versions for the intelligence community and the Air Force, but there's lots of other applications as well. Monitoring the environment, climate change. There's also medical applications. You can do energy exploration using it. So once you show it to people, it turns them into believers because they realize that, boy, this is something that could be turned into a product that, really could meet some of our needs.